All right, guys, review sheet's out. We're going over the review sheet today. We're finishing going over the review sheet today. The first one I want to look at is 16, because I don't think we got to 16 yesterday. We finished off at 15. Okay, I go. One. So when we look at 16, we're looking for a greatest common factor first. Always look for a greatest common factor. 12x squared plus 17x plus 6. And one way that it could be helpful, especially when you get bigger numbers, if there's a greatest common factor you see for two of the terms, try it with the third. Because here, 12 and 6 do have a greatest common factor of 2, 3, and 6. But 17, 2, 3, and 6 are not factors of it. So that's as far as it goes. You can just put it in the corner. So if we look at this here, again, with some of the bigger numbers, like the one we had yesterday, number 11, trying to see a greatest common factor between 49, 3, 43, and 7 might be hard, but 7 and 49 we can see is 7. Then we can use the calculator to check those greatest common factors with the middle term. Here, for 16, there is no greatest common factor between 12, 17, and 6. Mainly because 17 is prime. So we can move on to our two sets of parentheses with 3 spaces. Now we're going to find the signs. They're both positive. Since the third term is positive, the signs are the same and match the sign of the middle term. Yes. Now our factors of the first and third term, well, 12x squared. We'd have x and x. Now factors of 12, 1 and 12, 2 and 6, 3 and 4. 2 and 6. Factors of 6, 1 and 6, 2 and 3. Doesn't matter where I put the 2. So we can't do this here because, again, if the original one can't have a greatest common factor, 2x and 2x won't go together because we have a greatest common factor of 2. If we don't see that, we can still check it. It won't give us the correct middle term. So that's fine. So if I switched it, 3 and 2, 2x plus 3 is fine. We don't have a greatest common factor, yes? But 6x plus 2 has a greatest common factor of 2, yes? Okay. We can do 1 and 6. Well, if I put 6 here, greatest common factor is 6. Okay. Maybe I can put 6 here. Greatest common factor of 2. So I'd have to change the first ones. So 2 and 6, we've tried every single one. 3 and 4. So 6, okay. 6. So that one's out. 2 and 3. That's fine. 3x and 2, no greatest common factor. 4x and 3, no greatest common factor. And we can go on and check this here. 3x times 3x is 9x. Positive 2 times 4x is plus 8x, which gives us 17x. And that's the middle term we needed. So these are the correct factors. Now again, that greatest common factor bit, it's not a hard set rule. It's just helping us eliminate ones that we don't need to check. Because we went through 1, 2, 3, 4, 5 different possibilities, arrangements, and we're able to immediately throw them out before we did any multiplication, any working through it, because of that step. Now, if you go through these and see greatest common factor, and keep seeing it show up again and again, take a look back at the top. Because there's a chance that if no matter how I set this up, I always get a greatest common factor. Look back up here, because whatever that factor that keeps showing up, 2, be it 2, 3, look back at the top. It might be there. Does that make sense? So it still would factor, it just turns out that there was one, we just missed it. And on the test, if you do miss it and do have a greatest common factor still there, you're not losing all points, it's maybe a point. And I think on the whole test, that might count for 5. There's a very small portion of it that is factoring like this that would have one. So you still get it right if you factored it, it's just that point for pulling the greatest common factor out will be missed. But you get the majority of it. Does that make sense? Be ready for 17. 8x cubed plus 27. Is there a greatest common factor between these two terms? No, because 8's factors are, if there was one, it'd be 2, 4, or 8. 27 is not divisible by 2, 4, or 8. So we can look at our cubed root of 8x cubed and the cubed root of 27. Well, our cubed root of x to the third is, well, x. Now we do need to take the cubed root of 8. Oh. And it's 2. So it's 2x. Cubed root of 27 is 3. And if the number seems odd or seems a little weird, if that's the case, take whatever you got and put it to the third power. So we can put 3 to the third in the calculator, and 3 to the third. 3 to the third power is 27. 2 to the third power is 8. It will undo it. That way, if the number seems odd or seems off, seems like it's either too big, put it to the third power and see if you get back with what you started with. So this is the one with 3 and the one with 5. 3 and 5. Yes, plus minus plus, same, opposite, always end on a positive note, so plus minus plus. Our first set of terms are going with our 2x. So in the first spot, we'd have 2x. Here we'd have 2x squared, 2x to the first, and that's it. Other one would be 3. The middle term would be 3. And the last term is 3 squared. Now we do need to simplify the first term, well, just 2x plus 3. There's really no simplifying there. 2x squared, we need to square it. We're multiplying it by itself, which would be 4x squared, minus 2x times 3. 2 times 3 is 6, x. And our 3 squared gives us 9. And that's it. Questions on this here? Hopefully you're starting to see, especially with the sum or difference of perfect cubes, once we see the pattern of how everything gets put in, they all flow the exact same way. Questions on these here? If we have time, we'll come back to 18, but I do want to look at 19 next. 40x squared minus, or 40x squared plus 172x minus 36. Again, we should always be looking for greatest common factor. Huh? So if we can't immediately see what the greatest one possibly is, what's one factor of them all? 2. Take it out. So we can factor the 2 out, which will turn 40 into 20x squared plus. So I can just divide each of the terms by 2. So we can see that 2 works again. Because if we divide it by 2 again, we should get to this here. And then we're done. So There are different ways to get the greatest common factor. We've done a few of those. But if you do see one, factor it out and then go again. There's nothing that says that we have to pull out the greatest common factor first. It makes it easier if we can, but it's not necessary that we do it first because we pulled out the common factor of 2 and then saw 20, 86, and 18 still has a common factor of 2. So we pulled it out again. Now at this point here, well, besides 10, because 10 does not go into 43 and 9, the only other factors of 10 are 2 and 5. Well, it may be easy to see that 43 is not divisible by 2, and neither is 9. And 5 doesn't work for either of them, so we are out of greatest common factors, or common factors. But whenever we pull out more than one, we've got to multiply those common factors together. And 2 times 2 is 4. So it works out that the greatest common factor between 40, 172, and 36 is actually 4. Now our signs would be opposite, and because of the fact that the third term is negative. Bless you. Because when the third term is negative, our signs are opposite. If the third term is positive, the signs are the same and match the sign of the middle term. Now we need our factors of the first and third term. 10x squared, well, we'll have x and x. Now 10, 1 and 10, 2 and 5. So we can do 2 and 5 first. Factors of 9, 1 and 9, 3 and 3. 3 and 3. Let's go with purple. And we can check this here. 2x times negative 3, negative 6x. 3 times 5x is plus. And we're trying to get to 43x. So that there is a little bit off. So we can switch, I would switch the 3 and 3, but switching that doesn't change anything. Switching the 1 and 5 for this here would not change, well, it would and it wouldn't. Mainly, all it would do is change the sign, because instead of the 5 being multiplied with the positive, it would now be multiplied by the negative 3, and same thing with the 2, which will just change it from positive 9 to negative 9. Now we can switch to 1 and 9. Yes, and I think this is not going to be the right setup, because 2x times negative 9, negative 18. 1 times 5x is plus, would be negative 13x. Okay. So I can switch to 1 and 9. 2x times negative 1 is negative 2x. 9 times 5x is plus x, which is 43x, which is the middle term we wanted, yes? And it has the correct sign. So 4 times 2x plus 9 times 5x minus 1 would be the correct answer. Questions on this here? We're good with this here? Now, just an insight, because again, when I grade these here, if I was grading this one here, the first thing I would look at is greatest common factor. Is it there? Is it the right one? Then I would look at the signs, plus, minus, factors of the first term, factors of the second. Are those two placed in the right spots? And most likely this would be greatest common factor is 1, factors of x, signs, factors of our constant terms. And if you got all those, you got them. Or just points going that way. So it is possible to get the signs right and not have anything else right. You still get those points. We good with this one here. 19. Were you I think there was a question on 21, or was it 22? 24? Okay, because I was going to look at 22 next. 31,250 and 93,312. Greatest common factor. 2 works, yes. So we can factor 2 out of both of these. What else can we factor out? Why? Because there's a good chance 4 is going to work, because 31, 250, 15625 x cubed minus 4, 6, 6, 5, 6. I think that's it. Okay. Well, at this point, we know 2 is not a factor. Yeah. And it might be hard to see these here. Well, what's 15625? 25. Well, at this point, if it's hard to see if there is another one, take the cubed root. Take the cubed root. Because if it works out that, say, that there is another factor of 2 or another one in there, that's most likely going to give you a decimal. The only way it wouldn't is if the greatest common factor is also a perfect cube. So if the greatest common factor was 8, we could still take the cubed root of it, because the greatest common factor would simplify as a cubed root. But again, at that point, I would not stress over it, because again, factoring it, getting it factored is going to be more important if you don't pull out that last greatest common factor. Cubed of what? 46656. Let's try. 46656. I'm making sure my spaces are a little bit bigger this time, because the last time we did one of these, everything got a little squished. So again, if there is still a greatest common factor, especially on the test, and you miss it, that's fine. Get it factored, because you're going to get more points from factoring it than you would missing that one. Does that make sense? So here, signs are the same. Opposite always end on a positive note. So we'd have minus, plus, plus. Our first term was 25x. And the next one we have 25x, that term being squared. The middle one we have 25x to the first. And then in the last spot, our other spot is 36. Middle term's 36. 36 squared. Now 25x squared, we're going to square both terms because we're doing 25x times 25x, so 25 times 25. There's no way it's 625. Okay, never mind. Because our 25x squared is going to be 625x squared. Our 25 times 36 is 900. Yep, 36 times 36 is 1296. Now, again, again, with greatest common factors, it looks like there might be one between those 625, 900, and 1296. Well, if there is one, there was most likely also supposed to be one in the first set. Because if we did leave one in, it's to a cubed. So one of the factors would be left in the first set of parentheses, and the other two would have been left in the second. Well, 25 and 36, there's nothing that goes into both of those. So greatest common factor between 625, 900, and 1,296 is 1. There's not one between those three. Between 625 and 900, there's one. 912, 96, there's a few, but not all three. Does that make sense? So that is the final answer. And again, those numbers are big. It looks like it is a complicated problem, but really we did what? We found our two terms, plugged them in each spot, and then did our calculations and got the answer. Questions on 22? Is there a greatest common factor between 8x cubed and 64y cubed? 8 can go into both 8 and 64, yes? And we can factor it out. Now this one here would have worked even if we didn't take the greatest common factor out. Because the greatest common factor is 8. 8 is a perfect cube, so it would have factored, but that greatest common factor would have been distributed out. Yeah, we can't take the variable out. If it had been, well, it wouldn't have been x cubed and x cubed. That'd be x cubed and x squared, which we'll see one like that here in a minute. Then we just pull the greatest common factor out and we'd actually be done. Now here, the cubed root of x to the third, cubed root of 8 y to the third. Well, the cubed root of x to the third is x. Cubed root of 8 is 2, and our cubed root of y to the third is y. Our signs would be minus, plus, plus. Same, opposite, always end on a positive note. First one, yes, because we would have x squared, x to the first, no x term. Then our 2y would be 2y, 2y to the first, and then 2y squared. And when simplified, we'd have 8 times x minus 2y times x squared plus 2xy plus 4y squared. Questions on this here? Because I miswrote it. Oh, because I divided it by 2 instead of 4. Because we pulled out because you had that common factor of 4 between the three. I pulled out 4, 4, and then for some reason 2. Yeah, so it would be 4. Yeah. So that's where I was saying on the previous one where we would have one of the factors, because 8, 2, and 4. Because 8's 2 times 2 times 2. One of the factors is 2 is in the first, the other 2 in the second. Yeah, so the 8 would have been distributed. 1 for our linear, 2 for our quadratic. Questions on 23? We good with 23, yes? We are skipping 24, 25, and 26 because there are no factoring by grouping on the test. No. All right, we're looking at 27, 28. 27 and 28. Now 27 does have, let me look at 24. 24 is like 1. Yep. So there's just a greatest common factor between the three terms. We pull it out, and then we are done. We'll have, hopefully we'll have time at the end. We'll cover it. If not, I'll cover it after the bell. And if I need to write a note, I'll write a note. Let's look at 27. Guys, let's focus in. 27, 12x cubed minus 144x squared. Again, as I've been saying the last 2 days, greatest common factor. Look for that first.
It's 12.
Because 12 will go into 12 and 144. We have x cubed and x squared, yes? So we can take an x squared out. If we take 12x squared out of 12x cubed, we're left with x minus. If I factor 12 out of 144, we're left with 12. X squared factors out completely, and we have this here, yes? The degree of what's inside the parentheses has now become 1, because the biggest exponent attached to a variable is 1. Once you get a degree 1 inside the parentheses, you are done. It just guarantees it's as factored as it can possibly be. If it's a degree 2, it can. We've seen a few already yesterday that didn't factor. But having a degree 1 inside the parentheses immediately guarantees it is done. Three of them. There's 3 of these on the test. The next one, 15x squared plus 30x. If we factor the 15x out of 15x squared, we're left with plus. As if we take 15 out of 30, we have 2. And that's it. And that is it. Now, if there are some, so Collier, as you're saying, some like this and you're not sure it's this, factor out the greatest common factor. Even if you do get stuck there, you will get some points for factoring out the greatest common factor. And it could be that it's one of these here and you actually got the final answer. Even if you do get stuck, don't know what to do afterward, do what you can and know what to do, and then go from there. Now this here is the last one we're going to look at. This one is going to be one of the bonus. This is the bonus. Here, yes. Now, this does look like it's a lot harder than everything we've done so far, but it is the exact same. We can treat it the exact same, and the reason we can is because the middle term is x squared, and the first one's x to the fourth. So if we factor this like we've been doing, since the third term is positive, the signs are the same and match the sign of the middle term. Negative and negative. Guys, let's focus in. Factors of the first and third term. So we need to see what times itself is x to the fourth. Well, we do have a few for x to the fourth, because we have x times x cubed. Because when we multiply like bases, we add the exponents. But for this here, no. What it actually is x squared times x squared. And the reason for that is because if it's x and x cubed, we need more terms in that quadratic. So it'd be x squared in the first, x squared in the second. Because if it's this fourth, x to the fourth and x squared, just like x squared and x here, x squared and x squared. That's the only set of factors that'll work for these. And if it had a number in front, we would do the same thing like we've been doing. Factors of that first term, list them out and try them. 256, 2, 1, 18, 7 or 8. 3 doesn't work. 4, 5, no. Because 4 should work. 64, thank you. 5 does not work. 6 does not work. 7, I don't believe works. 8, I believe in 32. 9 does not work. 10 doesn't work. 11 doesn't work. I'm wanting to say 18. No, 16. Dang. 16 and 16. Now we can check this here. X squared times negative 16 is negative 16x squared. Negative 16 times x squared is that the middle term we wanted? Yes. So is that a lot different than what we did? No. It is pretty much the same exact process. It's just instead of having x squared and x, we have x to the fourth and x squared. It looks harder, yes. Now again, we said if the degree in each set of parentheses is 1, we're done, yes? What's the degree in each of these parentheses? 2, yes? So x squared is a perfect squared, yes? Is 16 a perfect square? Yes. So x squared, the first one, x squared minus 16 is the difference of perfect squares, yes? What about the other one? If it asks for fully factored, we need to go all the way down. You'll get at least half credit for getting there. Because x squared minus 16, difference of perfect squares, yes? Difference of perfect squares, the signs are automatically opposite, yes? What times itself is x squared? What times itself is 16? Well, the other one's the exact same, isn't it? So the fully factored form is x plus 4 times x minus 4 times x plus 4 times x minus 4. There's only one that looks like that, and it's bonus. Because I threw it in the end just to see, taking it a step further. Because I've talked about this a little bit because I've said college algebra is just one step further than what we do in here. This is one of the steps. It's just taking what we've done and putting it in a new context. And we'll learn ways to do this, especially with what we call U substitution. But we have this here. Now 24, if we look at this here, purely looking at variables first, A. Now, the most we can take out is a to the first because the middle term is to the first. So that's the most we can remove from those there. B squared, B cubed, B to the fourth. B squared is the most we can take out because that's the smallest exponent attached to B out of the three. First one doesn't have C, second one does, third one doesn't, so we can't remove C. Now 186, 9, and 117, well, the only factors of 9 are 1, 3, and 9, so 3 and 9 are the main ones we would look at. 186, 3 does, 186, 9 does not, so 186 tells us our only possible choice is 3. Do you kind of see what I did there? Looked at those factors, checked the first one, threw 9 out. 3 is the only one. Checked it with 117. So that means our other factor is 3. And if we remove, now we can remove this out of all three. 3 out of 186 would be 62. We remove an a from a cubed, we have a squared. B term is gone. Minus 3 out of 9, or 3. 9 divided by 3, we factor the 3 out, we have 3. We factor the a out, it's gone completely. We factor the b squared out, we have b. And we still have c. Plus our 117 divided by 3 is 39. If we remove an a from a squared, we have a. And b squared from b to the fourth is d squared. Now this is as far as it goes. One of the key indicators that this one's done is we don't have, especially the a squared a number without a. We do have a squared, we do have the a and a number without a, but the bc thrown in throws everything off. Now we could have a and b squared, a squared for one term, b squared for one. The middle term would have to have a b, and it would work kind of like with the quadratic for sum and difference of perfect cubes, how it has that kind of pyramid effect. One's going down, one's going up. But the c is what throws everything completely out of whack. We can't factor any further. That's it. So that's all we're going to do today. Your test is tomorrow. Yeah. So if you want to give yourself a little bit more time, as soon as you get in here tomorrow, I will give you the test and go on and get started. Okay? If you do have questions tonight, looking over anything, ask, email me.